Okay, we are official. Okay, so we've now done 2 lectures about simplifying radicals, right? Now we're going to start to use what you've learned to actually add radicals, okay? Now, we sort of talked about this briefly in the last lecture, but I'm just going to review it really quickly. If I said 4x plus 2x is equal to 6x, right? You all agree with that? Right? Then 4 square root of 3 plus 2 square root of 3 is equal to 6 square root of 3. You guys all agree with that?
Yes.
You see how they're like terms? Because they share the exact same number under the square root sign, right? So I'm realizing that's not the best marker, so I'm going to change marker. But, so I could do, it doesn't really matter what's under, as long as it's exactly the same under the square root sign. So I could say 3 square root of 2xyz minus 2 square root of 2xyz. And what would that give me? Are they like terms, first of all?
Yes.
Yeah. It doesn't matter. Like, if this is confusing you, like, well, what is the square root of 2xyz? I haven't the foggiest. I really have not a clue. I'm a math teacher, and I don't know what it is. Doesn't matter. All I care about is, are they exactly the same? Yeah, they are. So that means I have 3 of these weird things, and then I have 2 of these weird things, and I'm going to take 2 of them away from those 3, which means I'm only going to have how many of those weird things?
I have negative 2 of those weird things.
Very technical terms here,
negative.
weird things.
Weird things, right? These are technical. If you get confused, always get out your math textbook and look up weird things, okay? That will always help you. Okay, so we have 1 square root of 2xyz.
I just put it.
Or just, you could say, or you could write it without the 1, right? Because everything 2xyz. That's fine too, right? Either one of those would be right. Okay, you with me on that? It's pretty straightforward. So, all right, so how about this? What would this be?
Well, the
2.
thises are very hard to understand.
Whoop, not 4. What did you say, Liam?
Thises are hard to understand.
This is hard to understand?
Thises are.
This is R?
These.
These are? But do you understand that as long as what's underneath the square root sign, I made it look weird on purpose. Because I just wanted you to realize that as long as the stuff underneath the square root sign is exactly the same, then you can, these are your coefficients, just like I did this. If I did 3x minus 2x, that would equal 1x, right? Pretend like x is just the square root of this. I have 3 of these. I'm going to take 2 of these away from the 3, and I have only 1 left over, right? So it's only the coefficient that you're adding or subtracting, right? Yeah. Yeah. So watch. What about this? 2 square root of 3a plus 4 square root of 5a plus 5 square root of 2a. What would that be? You have to look for the like terms. This has a 3. Oh, wait. Sorry. That was supposed to be a 3. There were no like terms. All right. So there's like terms there, right? So now I have 2 of these 3a, square root of 3a's, and I have 5 of these square root of 3a's. So how many? That looks like a 9. Jeez.
That's scary.
I know. So how many square root of 3a's do I have total?
7.
7. So I'm going to write that. 7 square root of 3a's plus 4 square root of 5a's. I cannot combine those, so I'll have to just leave my answer with 2 terms, right? With a plus sign in between. Because they're not like terms. Just like I couldn't add 7x plus 4y. I can't combine them. I have to keep them separate, right? Okay, so can I erase all this? Because now we're getting into the real thing. Okay?
What's that?
The real thing. And some of you there were actually a few problems on the homework, and I told you guys didn't have to do them. I don't know if some people did them. But let's say,
The second page was really hard for me. I just didn't understand.
Okay.
it yet.
right, and so like towards the end of the second page on the homework, there were problems when you had square roots, and what was underneath the square roots were not the same numbers, right? And so we're going to try some of those. Like, in fact, did I pick up the homeworks? What did I do with them?
Gary.
All right, so I'm just going to use some of the ones that were on the back here. So we have the square root of 12 plus the square root of 48. And we're thinking, oh my gosh, they're not like terms because the numbers are totally different in there. So what you try to do is you simplify each one. You have to simplify each one. So, again, remember, we're going to have to be sure I'm on. Okay. So we're looking for our perfect squares. That's the only thing we care about. 4, 9, 16, 25, 36, 49, 64, 81, 100, right? I always put those out there when I'm doing these. You know, it's so easy. Just write them really fast on your paper. The first thing, when we simplify this, the first thing is going to be the square root of one of these numbers. 4. All right, 4 goes into 12, right? 4 times the square root of 3. Square root of 4 times square root of 3, yes? Okay, plus, what goes into 48? What's half of 48? Half of 48. 24, right? 24. So I'm going to go to 24. That's 25. So it's got to be either 16, 9, or 4. I'm going to start with 16. 16 times 3 is 48. All right, that's good. So the square root of 16 times the square root of 3. Okay, what's the square root of 4? 2 square root of 3. Notice how I'm doing this vertically? I have everything right underneath everything, so it's really easy to, what's the square root of 16? 4 square root of 3. Do I have like terms now?
Yes.
Yes, look, square root of 3, square root of 3. I have 2 of them, I add 4 more to them, how many do I have?
6.
I have 6 square root of 3s. And that's my answer. Right? So it makes sense? It's just a matter of simplifying them first.
Simplifying.
Simplifying.
Simplified it.
Okay, we'll try another one. So, square root of 32 plus the square root of 18. So again, I'm going to, underneath this square root of 32, I'm going to put the square root, and it's going to be one of these numbers always first. If one of those numbers does not go into 32, I can't simplify square root of 32. And I won't bother. Okay? Square root of 32. So what's half of 32? Oh my God, 16 is a perfect square. So I'm going to immediately start with that. 16 times the square root of 2. Plus, what's half of 18? 9 is a perfect square. Oh, that's great. Square root of 9 times the square root of 2. All right, square root of 16 is? 4. Square root of 2. Plus 3 square root of 2's, right? So they're like terms now. Look at that. That's awesome. So I have, how many of square root of 2's do I have now? 7 square root of 2's. Right? So that's my answer. Can I erase the left one? Can I erase this one? We're just going to do each one of these that are on here just so that we get really good at them. Okay. This is good actually. Now look, now So far, the only things I've been giving you are where it has a hidden 1 in front of each one. Now we're going to try one with a number in there. Okay, see how that how that changes things. It doesn't change things too much. 2 square root of 72 minus 5 square root of 8. You look at that and you think there's no way we're ever going to combine those, right? I mean, that's what a math teacher would look at. There's no way. But turns out I'm wrong, right?
36 times 2 is...
Right, half of 72 is 36. 36
perfect square.
is a perfect square. So I'm going to put I'm going to keep this 2, and I'm going to put the square root of 36 times the square root of 2. Yes? Minus, I'm going to keep that 5, and then I'm going to put square root of half of 8 is 4. 4 is a perfect square.
Oh, wait. Do you multiply those?
Square root of 2. Yes.
I did that wrong.
So now everybody's with me on this? You understand how we got there? Does it make sense, Lena? What we did? All right. So what's the square root of 36? So 2 times 6 is, well, I'll just write it like this. 2 times 6 times the square root of 2 minus 5 times 2. Square root of 4 is 2, right? Times the square root of 2. So now, what's 2 times 6? Yoo-hoo.
8 12.
Right. 12 times the square root of 2 minus, what's 5 times 2? 10 times the square root of 2. Oh my gosh, I have like terms. This is like so exciting.
6 minus 5.
Like terms. So
The
yes.
answer's negative 1.
So what do I have? I have 12 of them. I take 10 of them away, so I only have 2 left over. 2 square root of 2's.
Oh, yeah, right. Yeah, it's the same thing.
Which one did I miss? Okay. All right. We'll do another one like that. 10 square root of 12. Am I going too fast?
No.
2 square root of 48. Okay. So, half of 12 is 6, right?
Yeah.
Yes.
So I go over to 6, and there's no 6, so I have to go below that, which is 4. Ah, good. You guys okay?
Yeah.
10 times the square root of 4 times the square root of 3 minus 2 times the square root of, okay, 48. Half of 48 is 24. 24 is just below that, so it's going to be 16, right? 16 is 16 times 3, right? So the square root of 16 times the square root of 3. All right, so now I have 10 times square root of 4 is 2 times the square root of 3 minus 2 times the square root of 16 is 4 times the square root of 3. So final answer is 20 square root of 3 minus 8 square root of 3, which is equal to 12 square root of 3. I'm just subtracting 8 from 20.
I knew that.
Right? Pretty straightforward. Now, last one, and I'm gonna do it as with 3 terms in it. Is that okay?
Yes.
I just have to make one up really fast. Okay, that'll work. Hang on 1 second. I'm doing this really fast. 18. Wait. Okay. All right. So here we go. 2 square root of 27 plus 3 square root of 75 minus the square root of 108. Okay? So, again, it looks like there's no way these are all going to simplify into one simple thing. But you never know.
Oh,
It might. So, half of 27.
3 and 9.
3 times 9.
Oh, yeah. So, yeah, 9 times 3. Perfect. So, I'll do 2 times the square root of 9. Always, it's the first one is going to be one of those terms times the square root of 3 plus 3 times the square root of,
25 times 3.
yeah, 25 times 3.
Minus.
Again, 25 times the square root of 3 minus, what's half of 108?
54.
54. Okay, we're going to go to 54. Okay, there's 54 somewhere in there. So we got to check 49. So you guys,
49,
I've got a video happening.
I think 3
All right, so where was I?
Now 49.
Half of that is 54.
36.
54.
3 times 36.
So 49 doesn't go into 108, but 36 times 3 is 108. You can get your calculator, put 108, divide by 36, and you'd find out that it works, right? So, square root of 36 times the square root of 3. So, we got 2 times what?
3.
3 times the square root of 3, right? Plus 3 times
5.
5 times the square root of 3 minus
6.
6 times the square root of 3. So, what do I have? I've got
6.
6 square root of 3's plus 15 square root of 3's minus 6 square root of 3's. So, do you see that? 6 square root of 3 minus 6 square root of 3, they cross out.
And I have 15.
So, I have 15 square root of 3's. Great. Pretty straightforward. They're actually kind of fun. I actually love doing these. Now that I have taught it, I'm going to tell you something. When these were this method of simplifying was invented,
Simplifying.
right? Simplifying. When this method was invented, we didn't really have calculators. You know, maybe we had a computer or something that could do it, but not everybody had in their house a computer. And I told you about when my dad first got his first calculator, right? Didn't I?
No.
I didn't tell you this?
Tutoring group.
I told the tutoring group? Oh my gosh.
Tell us now. Tell us some of
I remember I was probably your age when they came out with a home calculator, a personal home calculator. It was huge. It was like this big, cost $300. And you know all the things it would do? It would add, subtract, multiply, and divide, and that's it. And it cost $300. We got it for my dad for his, like, I don't know, some special event. Maybe his
Was he a
birthday.
mathematician?
And he, well,
Or a math teacher?
he was no, but he's very good at math. And actually, his dad was brilliant at math. He would my grandfather used to. This should not be on the video, but whatever. But my grandfather would actually. He was a mathematician at home. I mean, he would sit down in his free time and sort of play with numbers and facts and things. And he would write. We used to live in Rochester, and so he would write the University of Rochester math department with big questions on how would you solve this kind of a problem? You know, would this be a legal way to do it, or whatever? And the math department wouldn't know the answer. We have no idea. You know, they'd write back, have not a clue. You know, and so then he would invent these sort of ways to do it. Anyway, that was my grandfather.
Okay.
I'm not like him though, but yeah.
Now, like some calculators, this is the first one I've ever had that does it. It's got the square root button here.
Right. His didn't have that. It didn't have anything but what I said. It was unbelievable. $300. Now I can get them for $1.99 at Walmart's, right?
Yeah.
Actually, you can get them for 50 cents at Walmart's. I bought several.
Really?
Yeah. But and those do more than the $300 one that we bought, right? Okay. So what I was going to tell you though, this method. So guys, listen. This method of simplifying radicals was designed to make things easier for mathematicians when they had to simplify something, when they had, like let's say you needed to know what 6 times the square root of 3 was, right? Well, let's say you needed to know what the square root of 108 was. Who knows what the square root of 108 is, right? And so what they started realizing is, well, we can figure out what the square root of 3 is. We can have certain values, right? And it's easier to deal with the square root of 3 than it is to deal with the square root of 108. So if we simplify it and we know what the approximate value of square root of 3 is, then we can tell you what 15 times the approximate value of square root of 3 is. And they used to actually, when I was in school, we didn't have calculators for much of the stuff, and we actually had tables that would tell you the square root of 1 is something or other, the square root of 2 is something or other, the square root of 3 is something or other. It would table after you turned the back on the back of every math book, and there would be tables. I mean, pages and pages of tables. So that if you wanted to find out what these things were worth, I mean, what the value is.
Like, how sometimes we have to simplify things like
Uh-huh.
divide it.
Right. Say it again?
Like, if you guys had to simplify something by, dividing it, what would you guys do? And it was like this big number.
Well, that's,
They do it by hand. Gabe.
yeah, they do it by hand. They do it by hand. It's a lot of work. It was a lot of work. You guys have a lot easier than we did. I'll tell you. A lot easier.
How would you even figure
plus-
out the square root of 3?
But let me just tell you something though. The way things are nowadays, if you want to know what that value is, you just hit square root of 3 or 3 square root on your calculator and you instantly know it. So it would be just as easy with a calculator to just do these. I could do 108 square root and I have an answer immediately. Immediately. I don't have to simplify it first and then
You
multiply.
just knew you just happen to know what the square root or the cube root of 27 was. You'd just be like, plus,
Right.
you know,
But most of these are actually, most of the square roots, at least when they're prime numbers,
Isn't the cube root of
they are actually,
27 3?
say what?
Isn't the cube root of 27 3?
Yeah, cube root. Yeah, I think he meant square root. Did you mean square root?
Yeah.
Yeah.
But square root is. Wait, then why are you writing a 2 there? Because the whole thing is a square root.
Well that means 2 times the square root of 27. If I was gonna do the cube root, see,
And you put a little thing above
just
that.
just so you guys know, this is a square root sign, and there's actually a. This is important to know, guys. There's a hidden 2 right here. Domenica, there's a hidden 2 right here. See that? And that means it's a square root. And that means what number times itself? Twice. In other words, what number? 2 of them multiplied
It's like
times
basically what number
each
squared?
other equals 4. So that would be 2. But if I wanted to do cube root, I'd have to put a 3 here, right? So if I had 3 times 23, the cube root of 27, what number times itself 3 times would be 3 times 3 times 3. That's it. So if it's cube root, it means I'm looking for 3 of the same thing to come out as just 1 3. So the cube root of 27 is 3, right? Because we use square roots so much, we decided we don't need to write the 2 there. So if you don't see a number there, it's just automatically square root. So that's the end of the lecture and the end of the class.